Hello and welcome. In this video, we'll explore the fundamentals of xenobiotics, foreign substances that enter living systems. We'll learn what they are, their types, how the body processes them by metabolism, and their impact on health and environmental applications and concerns, biochemistry and pharmacology links. The term xenobiotic comes from Greek, xeno meaning foreign and bios meaning life. These are chemical compounds not naturally produced or expected within the body. They can enter the route ingestion, inhalation, or skin contact and others, and include drugs, pollutants, additives, and more. Xenobiotics are grouped into several categories based on their origin and use. Let's take a closer look at some of the most common ones. Pharmaceuticals such as antibiotics and painkillers are designed for therapeutic use but are foreign to the body and metabolized in the liver. Food additives like sweeteners and colorants improve taste and shelf life, but may cause reactions in some individuals. Industrial chemical and pesticides can pollute the environment and pose health risks throughout bioaccumulation. Carcinogens like asbestos and tobacco smoke can damage DNA and trigger cancer. Endocrine disruptors such as BPA interfere with hormones, particularly affecting children and fetal development. Cosmetic and recreational drugs may be absorbed throughout the skin and causing toxicity. Our body processes xenobiotics. There are two main phases of metabolism. Phase 1, the compound is modified by oxidation, reduction, or hydrolysis using enzymes like cytochrome P450. In the phase 2, the modified compound is conjugated with molecules like glycerolic acid or glutathione to become water soluble and easily extracted. Not all xenobiotics are harmful. For example, drugs can heal, but many pose health risks. Toxicity depends on dose and exposure duration, route of entry, and individual susceptibility. Mechanisms of toxicity include receptor binding, oxidative stress, and DNA damage. Effects range from acute toxicity to cancer, birth defects, and neurological disorders. Xenobiotics have valuable applications in medicine, agriculture, industry, and bioremediation. But they raise concerns: toxicity to humans and animals, environmental accumulation, antibiotics and pesticide resistance, regulatory gaps due to the rapid chemicals innovation. As biochemistry links with xenobiotics, enzymes are biological catalysts made of proteins. They accelerate chemical reactions, including the metabolism of xenobiotics, without being consumed. Their active site binds to a specific substrate, forming an enzyme substrate complex. Enzyme's activity is influenced by temperature, pH, and the presence of inhibitors. Understanding enzyme function is essential in xenobiotics metabolism. The links with pharmacology, pharmacokinetics is how the body handles drugs. By absorption, how the drug enters the bloodstream. Distribution, how it spreads the raw tissues. Metabolism, how it's broken down, often in the liver. Excretion, how it's eliminated, mostly the raw urine or bile. Pharmacodynamics is the study of how drug affects the body. It focuses on the mechanisms of drug actions, including interactions with the receptors, signal transduction pathways, and the relationship between drugs concentration and the resulting therapeutic or toxic effects. So, in this course, we covered what are xenobiotics, types and metabolism, toxicity applications and concerns, biochemistry and pharmacology links, and we discussed their importance. Understanding xenobiotics helps in designing safer drugs, improving environmental safety, and managing toxicity effectively. And thank you for watching. If you have any question or would like to learn more, feel free to reach out or leave a comment. Stay curious and see you in the next lesson.